In this problem, we're given a convergent series, and we have to select all of the reasons that that are correct for why this series converges. All right, so just to be clear, this thing does in fact converge. And A is a valid reason for why it converges. It has a similar tail thickness to 1 over n to the fifth. I mean, an does. And the series 1 over n to the fifth is a p-series with p equals 5 bigger than 1. We know the p-series test. All right, part B is not a valid reason for why this series converges. That's because this is not a geometric series. Remember, a geometric series has the form, this is a number in here to the n. So for example, 2/3 or 1/3 or 5 or something, right? Remember, this is true that a geometric series does converge when we have this. That's absolutely true. But 1 over n to the fifth is not the form of a geometric series. Remember, it has to be a number inside the parentheses there. All right, part C is not a valid reason. So it's true that, let's see, the way that, remember the way I showed you before, let's see, n is less than n to the fifth. So that says that 1 over n to the fifth is less than 1 over n. And so then, yes, we do have this 1 over n to the fifth 1 over n relationship. So all of this is correct. And so that means that this is correct. But it doesn't tell us anything. And that's the problem. Smaller than divergent doesn't tell you anything. See, remember, this is a divergent series. So if you're smaller than a divergent series, that tells you nothing. This reason is not correct either. Now let's see why this is. Okay, so n to the fifth is less than n to the sixth when n is bigger than or equal to 1, right? And that's what we're dealing with here. We're always dealing with bigger than 1. So that says 1 over n to the sixth is less than 1 over n to the fifth. So putting that little thing there. So the relationship is incorrect. So this is incorrect there. It's actually, the relationship is actually this way. So that's why that one doesn't work. All right, this one does work. Okay, and this is because, let's see, we can look at it like n to the fourth is less than n to the fifth. So 1 over n to the fifth is less than 1 over n to the fourth. You can do this thing. This thing converges, right, because it's a p series with p equal 4, which is bigger than 1. And so we're smaller than convergent, which tells us convergent. So that's a valid reason for why it converges. Another way you can think of this, if you don't like doing this flip-de-doo thing where you have a less than b, and this of course is only when we're positive, tells you that 1 over b is less than 1 over a. This I call the flip-de-doo thing because it flips things around. If you don't like the flip-de-doo thing, then you can just think of it as 1 over n to the 5th, you're dividing by more, so it's going to be smaller than 1 over n to the 4th. If you divide by more, you're going to be smaller. All right, this is not a valid reason here. This reason, this is all true. This is actually all true. This is definitely a true statement. Since the limit as n approaches infinity of the an equals 0, this thing has a tail. That's absolutely true. It does have a tail. But going back to the series notes and learning goals, in the convergence and tail thickness section, it says, a series converges if its tail is thin enough. Series with fat tails diverge. Series with skinny tails converge. So just because you have a tail doesn't mean you converge. If you have a tail, then you're a candidate for convergence, but you still may not converge. All right, and this is a valid reason. Remember that the series converges if and only if the associated improper integral converges.